And now I hope everyone is doing great because we are moving to our next presentation. The topic is about building a large-scale web application and how to manage with the performance. As we know, like as more your application is being scaled, as harder is to handle the performance. But I think our speaker will help us with that. So let me present you Roderick. Uh,
Hi, everyone.
he is a very experienced software engineer leading a team in a very nice and popular company, Tinder. Many of you, I believe, used or is using the application. And yeah, let me give the stage to Roderick and go ahead.
Thank you very much. Hi, everyone. I am Roderick, and I'm really happy to be here today. And I hope you're having a great session so far at the conference, no matter what location or which time zone you're in. Understand like some places are already really late. I'm going to share some of my experience related to building a large-scale web application today. If you're about to start a new project or trying to scale up your existing React app, like from the prototype level, I believe that this topic will be helpful for you. So first start a little bit about myself. I'm a product engineer architect based in San Francisco Bay Area. I've been in the tech industry for more than 10 years now, and including some large corporate, startup, and some consulting service. I enjoy a lot building large the products on the web platform, as well as architecting the web app to have high performance and easily to be able to scale up. In my opinions, web application could provide the same delightful user experience, just like native applications. Also with the benefit of highly shareable and discoverable content. Product I built, including informations portal, news, weather, dashboard, and most recently, the dating app. So before we start the whole topic, I want to talk about what is scale in web development. First of all, when we talk about scale, it means that your app could handle a large scale of the user traffic, as well as handling sudden spike from events. Depends on your nature of the app. Some app might have similar usage across the whole week, but during weekends or like specific event like breaking news could spike the traffic like 20x or more. Your service should be able to provide a stable level of service all the time, or at least has a decent degrading mechanism so that the core functionality is not affected during the sudden spike. The next aspect we're talking about scale is like how easily for you to roll out your feature to more audience or market. Assuming like we have a feature that is already in bucket testing for targeted user, how fast it is for you to roll out the same functionality or features to more audiences. For instance, is your app is easily to be provide different language translation, CSS styling, or configurations based on the market needs. The next part is probably one of the most important part is when we talk about scale, we mean that you could adopt the similar development cycle to different features. So you can easily to replicate the development process and deploy the feature easily. On the other aspect, if you want to progressively enhance your code base, for example, a common example is I want to add a performance enhancement of my image loading strategy. How easily is it for you to adopt the enhancement to all of your code base without a massive code refactoring? It could be including something like tooling, standardizations, logic abstractions, or some best practices. The next part, I believe everyone here probably have similar experiences. Your code is maintainable and high performant when you just start to develop by yourself or within a relatively small team. However, the code becomes really complicated when there are new features added, the bundle size increase as the member join the team. Everyone programs differently. And if the code base or legacy code base, we say, has already a great code complexity and not easily to be understand, most of us, when we develop, we will start to craft out a conditional logic or to bypass or cloning the existing logic, like to avoid breaking production code. Then actually more tech debt is created along the way when your feature is added as a result. Without the good fundamentals or infrastructures, adding new features or code is more like adding a band-aid or ad hoc logic, and eventually will slow down your development process and cycle in the future. So the above I just mentioned are all critical when we talk about building a large-scale web applications. It's not just only about your web, it's also about like how you manage your team and how you manage your code to have the same level of the performance. So you might probably ask me, what will be the best React framework or toolchain to building a large-scale web applications? To answer this question, I think the front-end ecosystem has progressively enhanced greatly in the recent year, from the traditional way that server side is only handling the markup and the client side in charge of the interaction logic, to like isomorphic apps, which means you have similar rendering logic for both your server side and client side, to the most recently like serverless solution or full client side single web applications. All the above recent framework I mentioned here, like Create React App, Next.js, or Gatsby, to some more component-focused library, they're all having a goal to help you to scale up, but they are solving different use cases. Almost all the toolchain above provide zero configuration set up by default, as we know that most of us does not really have deep knowledge about optimizing bundling or JS compiler. Create React App is mostly the most simple one, provide the easiest way for you to start a simple application. A lot of people actually running production code using the framework from the Create React App. So it is maintaining mainly by the Facebook React team. So it becomes a really good playground for new React features, and it got a really good support from the core team. Gatsby.js, for example, is rendering most of all the pages in the build time and store in cache. So which fulfills most of the use case of your having a static content or a predictable data. It is a really nice architecture as all of your content is pre-built and stored on the edge, which means that it's closer to the user real location that's already optimized for network transmit. Next.js, on the other hand, focuses more on pre-rendering page and has really good at server-side rendering. So if your main purpose is to optimize for sharing, social sharing, or like SEO index, Next.js will be a good choice. Most of all the framework we mentioned here are able to scale up in certain way. Depends on how your web app is built and what use case you are optimized for. The talk today, we are actually not be framework specific. We will focus on a level of abstraction on top of the existing framework here, and to which make your app to be more extendable and maintainable to be scaled up. So this is the main topic we're going to talk today, abstractions. And you might understand abstraction in a certain way, or you might ask why we need an abstraction and what kind of abstraction do we need here. The benefit of abstraction could be really hard to notice when you just start the app. Sometimes you might feel that it's not straightforward to abstracting logic comparing just to implementing everything on the component level. It is true that sometimes it seems to be the abstraction be over-engineered, or it will create high learning curve for new members. So from my experience, it is always important to balance out the level of abstraction. But I would suggest that you always start thinking or in preparation of high-level abstraction when you found out that you start to duplicate the same logic or same steps while building your components. I will show some of the example of the benefit of abstractions here. The first and probably the most common practice is to build a common component. I believe it's covered in a lot of talk today as well. As React is actually a component-based system, by nature, you are already building a shareable component where you start React, which is a really good start. However, this is also one of the areas that is very easy to overlook or to make your code really complicated if you are not designing the abstraction properly. I'll share some of the common component practices that can improve your code app structure and make it easily to manage your code base. The common component by purpose, we can probably divide into three categories. I would say style, functionality, and logic abstractions. Note that those are not mutually exclusive. Some components actually provide multiple purpose, which is totally normal. The first we talk about is style component. So the style sharing is the most common reason that you're going to build a component. We cannot be emphasized enough about design system here. What is design system? Design system is a contract within your team across all the functions that how your web app should be built logically. Why you need a design system? Thinking of design system just like your coding style rules. Without the same rules or agreement among the team, it's very hard for people to manage the code base and moving forward. Let's say we have a UI button. This common component could provide the same look and feel and using the UI button across all your code base. In React, probably there are multiple ways we can handle styling. Most commonly used is passed by props, or using CSS or JS overrides, or using React context such as theming like dark theme or light theme. You might not have a design system at start, but if you keep scaling up their code base, it will be very problematic when your team is scaling up and more features to be added. Many of us experience that the UI components start to diverge when there are new designer coming or the feature that is not using the same design systems. For example, they probably will have slightly different color, border radius, padding, or font size that just slightly different and make the components start to handle different UI contexts. A button, for example, in login page might look just slightly different than other pages. And it will be harder for people when they're going to use your components because there are just so many style combinations to be choose from. This start to defeat the purpose of building a shareable UI. What is the downside of not having a design system? So as I mentioned before, components will be including a lot of unnecessary styling just for a very small variant, which could be like just totally unnecessary. In an ideal world, your common component should not be aware that which context it is currently in. As we know, UI context is tightly coupled with your business logic. For example, like login page or a checkout page or anything that is your business object. Your component will start to need to be handling all those business logic from the shared component base. It could potentially create two scenarios where people are trying to add more features or more styling here. First of all, it will have more if-else condition inside your component logic. It makes people very hard to understand without knowing other business logic. The other scenario we could happen is when people find out this component is hard to read or understand, you could be just cloning the style or fork the components, which also defeat the purpose that we basically just duplicate the logic and made the code really hard to be reused. Imagine like if you have a revamp of your current web app that need to change all the button style, and you have a lot of fork and copy or if-else condition logic inside the code, it will make you very hard to test out the whole part of your using a different combination of your components. Your app will look slightly different all over the place and increase the CSS and JS bundle size, hurting the rendering performance or caching, or just like not look well polished. So what can we do here? I would say be very, very cautious and picky about the CSS you are adding, thinking that you have a strict budget of adding a new style. You ask the team, if this small variant is really necessary to be introduced, or we could reuse the existing one. When the style is select or choose, is this using in the correct context logic, like for other page of what you are building? For example, if this is your primary button and putting in the main click action, is this the correct style you should use, or is different? There's no logic behind that. Collaborate with the team and document how or to use the common component. The next we're talking about is functionality. For example, if you want to have the image loading components with handling like image loading optimization, such as preloading, lazy load, or image placeholder, error handling, it is very, very good practice that you start to build common components. However, it is also one of the easiest place to have incorrect abstractions. Commonly mistake including that you couple your business logic into the shareable component. For example, if you have a component that have an optional footer to be displayed and controlled by a React prop, you should probably name the props using the feature instead of the context. For example, if your component have the optional footer, the flag of that prop probably should be show footer or should display footer instead of if this is in bucket A or if it's in logging page, because it will make it very hard to understand without knowing that which parent is currently in. The other common mistake we hear is to overly abstract the logic to be a super low-level component, like building a component just for one HTML tag. Overly abstraction, what is the downside is like make everyone going to use the low-level component need to handling the assembly logic and need to have deep knowledge about each component you are building and the API the component is providing. Without knowing that, it's make people just like very hard to use. Imagine that you have a lot of Legos brick, and it's not everyone can use the Lego build to build a really easy way to do. So if you have a template or have a certain level of the abstraction, it will make your function component will be much easier to be shared. Last part is to avoid adding ad hoc logic for certain use case. Let's say if I have a component that will have one different condition logic when it click on certain pages. Don't add an if-else switch that if this is in bucket A, do something else. Imagine that this thinking of you're adding an exception to a generic component, and everyone using this component will need to include this conditional logic. What worse is when new people or new logic need to add in. If you already have an if-else condition, most likely we will add more if-else in each statement, and you could create like waterfall logic. It will make the components start to really, really hard to share because you're blending those business logic. Last part is the logic abstraction, which is actually pretty easy now after we have React hooks. React hook is your friend to use it. I would say like, so let's say you have a component, your main flow of each step should be really clear. So each hook inside that could be black box to the component itself. But when people are reading that, the main flow should be very clear without knowing each individual logic. Before we have class components, everything technically is like inline into that. So you have to read through all the if-else or the inline function in order to understand the main flow. So React hook and the abstraction helps you to easily share the abstraction logic. Okay, so we already have a knowledge of how to properly build a common component, and I think a lot of people already did. And now it kicks in that we need to add instrumentation to collect some like performance data. If you're not familiar with instrumentation, it is just like some of the beaconing that's sent out when the component reacting to some user interactions. This part is actually a little bit tricky to handle properly and easily to make the good component we just built start to blend in to become a hard to be reused component. Mainly because instrumentation is also actually a business logic. So let's say, again, we have a UI button and we want to add an instrumentation when we on click. Assuming we're using Google Analytics, the common components it already have an on-click function here. So how should we add an on-click beacon? Most common way or easiest way is just to directly add in the instrumentation into the handler functions, and that's just code it a day. The problem is here, the component become tightly coupled with the instrumentation. If the same component is placed in other parents, technically the instrumentation should be different. So a lot of people might start to just duplicate the same UI logic or just to handle different instrumentation value. A better way is to move up the instrumentation into parents components and pass down as a callback function. Yes, this is somewhat abstract the logic to the container and make the single component build it to be reusable. Do we need another level of abstraction? It depends. This solution keep your common components clean, but not necessarily solve the issue that your instrumentation logic is not isolated. And more likely, you will always need a wrapper component to provide those instrumentation metadata when you use the common component. Some other consideration why we need another level of abstraction. Let's say if we want to add a new tracking system in our web app, such as a Facebook Pixel, or you want to deprecate one of the tracking system, or more commonly, like you have to able to send your instrumentation beacon only after user consent the shared data for like GDPR or related privacy regulations. What you're doing here will most likely will go through all your code base and modify the logic, which is highly expensive task when you want to execute it, and especially you have a large code base. And not to mention that it's very error prone. So one solution here is we could have a top level of the app beaconing handling. You will have the top level handling and your component basically just send the beacon when user interact. The component itself is not aware of which tracking system you're currently in. It only cares about dispatching certain event regardless of the handler. Or if, let's say, want to remove the handler, we can just remove the top level handler and everything will remain the same. Your top level handler will basically just listens to the event being fired and have the relative handling inside each callback function. I'm not going to into the implementation details, but there are several approaches you can use, such as using React context or JavaScript event system, such as event emitter. You could also add multiple listener here if you have a different tracking system at the same time. So you can see here, we basically standardized a click event, the payload of the click event, and you isolate all the beaconing actually in a separate file or separate logic, and we are all listening to the same payload. What is even better is we could leverage the React context to assign different event value from the parent. So if you're not really familiar with context basically is to set, you have a base context from top, and you can have a parent to override, so your child will be inherited from that parent's context. So using this logic, we could actually let the component sending exactly the same value, but the parents will be able to provide the context. So your event payload will be able to be aware of which context is currently in, but everything else will be remaining the same. Last part I'm going to share about here is routing. Routing is probably one of the most critical part of the single web application. It handles the client-side navigation and page rendering logic. We are using a React router here as an example. The most basic code structure is to have a switch component on top and handle component by route. You will soon develop a route-based component if you have this architecture. This architecture makes it really easy to understand from the top level and the main purpose of your each route. So what is even better here is we could have a code splitting easily. For example, in our example here, we actually utilize React Lazy to dynamically load the chunk when the page navigates to that route. So this architecture actually is a really good start. Why we need an abstraction here? Some common case is like, what if we have need to handle page animations or common actions such as on enter or on exit route actions, or we want to just simply assign a meta information for SEO like title, description, OG image of stuff. Where is the best place to place these informations? Obviously, the most straightforward place is to directly put in each individual route component. In our example here, the component will be about, users, and home. The downside of this approach is your route level components start to be aware like which route is currently in. As I mentioned before, the comment section, your child component should be unidirectional and not to be context aware. If your user component like here is shared by different routes, we start to complicate the logic, and we need to have a conditional logic to handle a different routes if we have a shareable component among different routing. So what we could improve here is to have a centralized routes config. You will basically standardize how your layout and route is rendering. For example, here, we could provide a meta title in each route config, or even provide an animation style for enter or exit action. And perhaps if you have a different layout, like one column layout, two column layouts, you could also standardize it here and just providing like rendering slot for your layout component to be rendered from the configurations. Some benefits including like clear abstraction. You create a very clean high-level app structure and easily to progressively enhance your layout logic, such as adding a preload prefetch to your next route, adding animation or on enter exit. You could even swap out all the routing library if you decide to change your client-side history management strategy without touching the component code, which will be really easy to migrate and test. I'll show some of the example of the benefit of this approach. Let's say we have a higher order component here, which is a create preload component. We basically wrap your current component we're using React Lazy and Suspense. If you're not really familiar with React Suspense, it's basically a conditional logic that helps you to hold the loading state until the child promise is resolved. The React Lazy is utilize the JavaScript dynamic loading and to be able to load the dynamic component in separate chunk. In this example here, we will create a dynamic loading component and only load the chunk when we navigate to that page. However, as the loading separated chunk require network fetching, user might see a delay of the navigated page before the chunk finish loading. What we can do here is to simply add a preload function, which could be invoked in some common user interactions, such as when the mouse hover a link, or if the link is within the viewport. We can then call a handle route preload function and basically just to preload that chunk in advance. Such as enhancement will not change any of your existing route architecture or components, and it could be easily to roll out for all your pages. Can we do better? Of course. So for example, here, we all know like preloading assets is will be a network request time. So ideally, we don't want to affect any high CPU or GPU intense actions, such as painting or animations. We could do is to only preload on the user idle time. There is some function provided by browser. Here is called request idle callback, which only execute within the timeout of the user, the window request time. This can also prevent some UI jankiness caused by high CPU usage. And if the browser does not support this, we could just have a set timeout or using requires animation frame to delay the frame to be executed. This make it really easy to progressively enhance your preload architecture. Can we even do more? Sometimes, if the network is really slow, preloading will occupy the network condition and block some of the important resource of your page. Preloading should be optional and low priority here. So we could utilize browser APIs such as Network Information API, and which tell you that what is the current network condition and dynamically change or opt in the preload routes when it needed. There are much more we can do, such as we can honor if user is in data saving mode and don't aggressively preload the resource to save users' data. All of the app level optimization we just mentioned can be easily isolated and adopt easily if we have a really good abstractions here. So to recap, the whole talk we are talking about here is to have good abstraction and centralized architecture. Some benefit of the centralized architecture is to have really clean logic isolation. You will start from standardization or how you're going to build an app by like defining how you're rendering your layout, what is the step you're providing. So everyone will building under the same standard. And you can progressively enhance all the feature one by one and easily without having regression issues. One thing to mention here is actually my talk is start from the UI component abstraction. In reality, you should always start from high-level abstraction first. You preparing your web app architecture to be extendable is one of the most critical things in terms of scaling up your web app. Once you have a really good architecture to scale up your app, adding more enhancement will be really easy for you to do. And adding more feature will not hurting your existing performance because everything will be isolated. So thank you for listening today. If you have any questions, feel free to reach me out at Twitter. And I'm really happy to hear about your experience of building large scale web application. And let's work it together to make web ecosystem stronger and better.
Thank you very much, Roderick. Was really a nice presentation. And I'm sure all audience enjoyed it. So we will also get questions from them. Well, I have one question from my side. As we mainly speak about the team and project scalability, in my company, the application that I was architecting, the solution that I picked was using micro front-end architecture. And I'm curious, do you have any experience on that? And what is your opinion on scaling applications with this architecture type?
From my point of view, like splitting out or a microservice or anything, it's still, from the team size point of view, is most important thing is standardize. You have to have a way to naturally standardize everything, like even if it's separated. So there's a lot of way we can do standardization. Some company opt in to be having a good tooling, so that the engineer will not need to handling like CSS or anything else. Everything will be black box. You will have a super good tooling that help you to do everything. But that will be like, basically, you will need a really strong tool team that help you to build the infrastructure. Most of us, we don't have the luxury. So what we can do is to standardize or have policy or how the process. For example, like Redux, there's multiple ways you can use Redux. And there are a lot of different ways you can combine with props, context, or anything else. It is really important for like your team, at least, to know what is the standard way to do and what is the trade-off we are selecting these options. Once you have that, it will be easy for you to scale up, or else like you will see that your development speed will be slower and slower, regardless which framework or architecture you are using.
Nice.
If that makes sense to you.
Yeah. Well, thank you very much.